Okay, so the doubt that we have here is root of 1 minus sin A divided by 1 plus sin A into root of 1 minus sin A divided by okay, we have this. We have been given this up till here, isn't it? So this is given root of 1 minus sin A by 1 plus sin A. And you have to show that that is equal to secant A minus tan A. Okay, so this is the LHS. This is given to us. This is the RHS, right? So we have to progress from LHS to RHS. So we can do it in different ways. Method 1, rationalizing. So root of 1 minus sin A by 1 plus sin A. So within the roots itself, if you consider this as expression, it's just like rationalizing. So you multiply by 1 minus sin A. Why? Generally, it's a good advice to rationalize the denominator. So we have 1 plus sin A, multiply it with 1 minus sin A. So that gives you what? Root of, now in the numerator, it is 1 minus sin A the whole square divided by 1 plus sin A into 1 minus sin A is what? A plus B into A minus B form, isn't it? A is 1, B is sin A. A square minus B square, 1 square minus sin square A. And of course, we know what is 1 minus sin square A, that is root of 1 minus sin A the whole square, numerator. So what is the denominator here? See, I'll just mark it in some other color. You can see, this denominator. What is 1 minus sin square A? It is cos square A, isn't it? So let me go back to black. Okay. So it's cos square A. So this would be, you can kind of write it as 1 minus sin A the whole square by cos A. The cos square A means cos A the whole square. So, we know the root of A square is A, isn't it? So numerator, denominator, both we have the roots, right? So what do? We take it out of the root, square and root. It becomes 1 minus sin A upon cos A. Now separate them out, 1 by cos A minus sin A by cos A. What is 1 by cos A? Secant A, isn't it? Reciprocal of cos is secant. And what is sin A by cos A? It is tan A. And that is nothing but my RHS, and hence proved. Okay, so here it was quite okay. We'll have to move to the next one, which is the next doubt. I hope this is clear. The next doubt is, yes. So let me write that down. So the next one is tan A plus secant A minus 1 upon tan A minus secant A plus 1. That's the LHS, and we need to prove that is equal to 1 plus sin A upon cos A. Okay. So we have quite a complicated expression in the left-hand side, relatively, and the simpler one on the right-hand side. Okay, we have a simpler one on the right-hand side. Okay. So now, it's obvious here. I have to take the path of rewriting tan in terms of sin and cos, secant, everything in terms of sin and cos. That is one approach. The other approach is, see, I look at tan and secant. I know there's a relation between tan and secant. What is it? 1 plus tan square A is equal to secant square A, isn't it? So this one probably I can rewrite it in terms of something, isn't it? 1 is equal to what? You take the tan square to the other side, it becomes secant square A minus tan square A. This one. Now, let me not change both the ones. For now, I'll just look at the denominator one and see what I can do. Okay. So left-hand side will be what? Tan A plus secant A minus 1. What is 1? I can write 1 as secant square A minus tan square A, isn't it? Related to this, divided by, I will not change the denominator now. For now, let me not change the denominator. So it will not, I don't have to replace the 1 from the denominator. Let me keep it as it is. So some small substitution. So let tan A equal to, let's say, some A. Okay. Let secant A equal to some B. This is a simpler way for us to understand. So wherever there is tan, I put A plus B. So secant, I put B. Okay. So tan A plus secant A is A plus B. Minus, what is secant square? B square, isn't it? Tan square is A square. This is a little easy for me to understand. So I've just replaced the 1 in the numerator in that format. And tan A is what? A. Secant A is what? B. Plus 1. Okay. See now what happens. Now, this is in the form B square minus A square, or I'll just take the minus out. Numerator, see. A plus B minus B. I can make a plus there, isn't it? There's a, I'll just show with the pointer, 1 minute. So, see, there's a minus here and there's a minus here. I'll just reverse the order and put a plus here. So, B square minus A square, there's a minus out, isn't it? So, I'll put a plus and now it becomes what? It's going to become plus A square minus B square divided by that denominator, let it be as it is, A minus B plus 1. I'm not doing any change. I mean, I can just keep the bracket also. Actually, there was no need of the bracket anyways. Because actually, when we are doing trigonometry, as we progress, we'll understand what to do next. Okay. So now, numerator is A square minus B square, isn't it? So what will it be? A plus B plus, what is A square minus B square? A plus B into A minus B divided by A minus B plus 1, isn't it? So I'll just take this to the next page because I don't have space here. So what will that be? A plus B plus, what was it? A plus B into A minus B. A plus B into A minus B. And it was A minus B plus 1, isn't it? Denominator. A minus B plus 1. Remember, at the back end, we need to back substitute. Small a is secant, small a is tan A, small b is secant A. All right. So now what happens? So you see, it's like x plus x into y, isn't it? A plus B plus A plus B into A minus B. You're understanding? So you can take out x common. It will be left with 1 plus y, isn't it? If A plus B is x, so same thing here. I can write x as x into 1, isn't it? And we can take out x. The same logic we apply here. So A plus B into 1 plus what is remaining now? This one, A minus B. I'll just show it to you in, see, so this component, I've taken it out, see. This component is taken out common. You're left with 1 plus A minus B. Okay, divided by A minus B plus 1. Now just rearrange your numerator. Addition is commutative, isn't it? So plus A minus B, I'll write minus B and plus 1. It's just, I just change the order of the terms. See, and then A minus B plus 1. You see now what I've done. See, I've just changed. A is plus A, it's come here, minus B and plus 1. 1 means plus 1, it's come here. So what is it? The numerator and denominator, these common factor gets cancelled out, leaving me with A plus B. Okay, so what is A now? Tan A. What is B? B is secant A. Just look back, that's what we have substituted, isn't it? B is secant A. What was expected of my right hand side? This. So I still don't have what I want, isn't it? But now no problem. I can rewrite it as this because we want 1 plus sine and cos. That means we have to rewrite tan and secant in terms of sine and cos. Tan is what? Sine A by cos A plus secant A is 1 over cos A. and that gives you sin A plus 1 or 1 plus sin A, because that's the way it's mentioned in the right hand side, over cos A, which is my expected RHS. See, sometimes you might also have a problem which ends with this tan A plus secant A, the proof, yeah. And in some cases, they might even ask you to show it in this manner, 1 plus sin A. It's just that you have to see how you can change tan and secant to sin and cos. How you tweak in that one is important. One is secant square minus tan square. Okay. So see, always don't, we might be tempted to even change the one for the denominator in this case. Don't do that. You can just leave it at the secant square A minus tan. So leave the one here and see if something is going to get cancelled. Yes, that's it. So I hope the explanation has been helpful to you. Okay.